Assume a vertical electric field of magnitude 3 times 10 to the fourth newtons per coulomb exists above Earth's surface on a day when there's a thunderstorm. Let's say that a car with rectangular size 6 by 3 meters is traveling along a dry gravel roadway that's sloped downward at 5 degrees. We want to find the electric flux through the bottom of this car. First, I'll draw the situation. Let's assume our electric field vectors are pointing down toward Earth. And we want to calculate the angle between the bottom of the car's area vector and that E field. So which way will the area vector point? The area vector is going to be normal to the surface. So it's got to be 90 degrees to it. And if our slope here is 5 degrees, then by geometry, that makes this angle 5 degrees as well. This is the area vector. In order to calculate electric flux, we need the dot product of E dotted with A. Now, one of the formulas that we have for dot product is the magnitude of E times the magnitude of A times the cosine of the angle between them. So here we've determined that the theta between them is going to be 5 degrees. Our electric field magnitude is 30,000 newtons per coulomb. And the size of the area of the car's bottom is going to be 6 times 3, which is 18 meters squared. Let's plug in everything that we have and find this electric flux. It's 538,000 newton meters squared per coulomb. The flux through that surface will be positive. In other words, field is flowing out of the car's geometry through that particular surface.